Okay, so in this lesson we want to have a look at residual analysis. We'll also look at regression analysis a little later on, but all regression analysis is bringing together everything we've learnt about regression in this chapter. So the new idea we want to first focus on is the idea of residuals, okay, and using what we know about residuals, or using the residuals to think about the situation that we're dealing with our particular data set. So the first thing, we did talk about residuals 2 videos ago when we talked about the least squares regression line, okay? And we talked about the idea of the residual sort of being the error in terms of how far away is the data point from the line of best fit. Okay, so, and by how far away, I mean the vertical height, so the difference in the y values. Okay, so the residual value, remember we also looked at when we had points that were above the line of best fit, they had a positive residual. Okay, so the residual there was positive, the height was above the line of best fit, whereas when we had a point that sits below the line of best fit, it has a negative residual. So if we want to calculate the residual for a particular data point, we want to calculate the actual data value, so the actual y value of the point, minus the predicted value, so the prediction that the line of best fit or the least squares regression line gives us. Okay, and so therefore when the actual value is higher than the predicted value, that is when the point sits above the line of best fit, the residual will be positive. When the actual value is lower than the predicted value, that is the point sits below the line, we'll end up with a negative residual from this calculation. Okay, let's have a look at an example. So here we've got a set of data showing the number of people on 8 fundraising committees and the annual funds raised. Okay, so we're seeing, for example, that a committee that has only 3 people on it, they managed to raise $4,500. Whereas the committee with 7 people on it managed to raise $10,000. There was another committee of 3 people, they raised $4,700. Okay, so we've got 8 different committees of varying sizes and how much money they raised. Part A, find the equation of the least squares regression line, giving values correct to 4 significant figures. Okay, so to save us some time, I have already created a new document and entered in my data. I've named my columns, so I've got number of people in the left column and funds in the right column. So I'm going to do my regression equation, menu 414. Oh, my apologies, it's because I've selected a number of cells, menu 414, let's try that again. Okay, my X list is the number of people on the committee, my explanatory variable, number of people, and my Y list, the response variable, is the funds that they raise. Again, the equation will be saved to function 1 for those of you happy with the function notation, and the results are going to go into column C. Great. Okay, so here's my regression equation. Now I want to write down the equation using the relevant variables. It doesn't need to say that, that's implied. So our X is the number of people on the committee and our Y is the funds. Okay, so therefore the, may as well use the actual term, so annual funds raised is going to be equal to A plus BX, where A is, and we want 4 significant figures, 29.79 to 4 significant figures, plus B, which to 4 significant figures would be 1478, times the X variable, which is the number of people on the committee. Okay, so there's our regression equation with values to 4 significant figures. Part B, calculate the residual, that is the error of prediction, for the funds raised by the committee of 8 people. Give your answer correct to the nearest dollar. Okay, so let's have a look at the top here. Our residual value is our actual value minus the predicted value. So we've got the actual value from the table. When we have a committee of 8, we know that they actually raised $12,500. Okay, we want to use our regression equation to see what the regression equation predicts would be raised with a committee of 8 people. Okay, so we want predicted funds would be 29.79 minus 1478 times 8. Okay, so again, if you've got your function notation, you could do just f1 of 8. Sorry, I went to the scratch pad. My apologies. Let me go back to my current document. Tab over here. Make that a calculator page. Right, sorry. So in the same document, f1 of 8 would use your regression equation. If you... Oh, sorry, my equation's not right. It should be plus 1478. Sorry, that was just a typo on my part. So 29 if we're not comfortable with the function notation, no problem. We're just going to type this in. 29.79 plus 1478 times 8 gives me 1185. We want to the nearest dollar, 11854. Now, in this instance, and I assure you that in an exam or a SAC, they'll assume that you get the prediction is the same regardless of whether you use the exact or not. We actually get a different prediction, slightly, $2 different, depending on whether we use the exact function definition or the rounded values. So I'm actually going to use the rounded values. I'm going to, following on from part A, it told me to give my equation to 4 significant figures, so I'm going to use the example that I've got by typing the equation in myself. But in a test or an exam, I can assure you you won't be penalised for being more accurate unless the question says using your equation from part A, etc. Okay. Right, so my predicted funds based on the equation I wrote down to 4 significant figures is $11,854 that they should be able to raise. Now we know from the table that they actually raised $12,500. So the residual value, that is the error of prediction, is the actual value, 12,500, minus the predicted value, 11854. So 12,500 minus, again I don't need to type that number in again, just subtract, just go up and press enter in your CAS, is the residual value is 640 to the nearest dollar, $646. Okay, so therefore what we're seeing here, we've got a positive residual, which means the actual data value was higher than the predicted data value. Okay, so the prediction is an under prediction. Okay, in this case, the line of best fit is under predicting by $646. Okay, sorry, can't get rid of that at the moment. Calculate the residual error of prediction for the funds raised by a committee of 4 people. Okay, so again, we need to first of all use our regression equation to find the predicted funds for 4 people. Okay, so the predicted funds raised by 4 people is going to be 29.79 plus 1478 times 4. Okay, 29.79 plus 1478 times 4. So we get predicted funds raised $5,942 to the nearest dollar. And so then the residual is going to be the actual, which we should be able to get from the table. So a committee of 4 people, there it is there, raised $6,100. Okay, so $6,100 minus the predicted value, which is 5,942. And so 6,100 minus that value there is $158. So again, another positive residual. Okay, in this case, the line of best fit is making an under prediction, so the residual is a positive value. Alright, next we want to have a look at the idea of a residual plot. So actually calculating the residual value for each data point and plotting those residuals. Okay, so we've already worked out in the previous 2 questions, the residual for a committee of 8 people was 646. Okay, oh, sorry. So it was 646. Because the predicted funds was 11854. For a committee of 4 people, the predicted funds was 5942. And so the residual value for that data point was 158. Okay, so we want to continue that. So we want to work out what the predicted value if we had a committee of 3 people was. Okay, so again, we've already done these calculations, so we should be able to use our previous calculations in our calculator. So I've just scrolled up to the 29.79 plus 1478 times the number of people, and I'm going to change the 4 to 3 to work out what is the prediction if I have a committee of 3 people. Okay, to the nearest dollar, that's 4464, so that will be the same for both of those. And then therefore the residual is going to be the actual minus the predicted, so 4,500 minus that predicted value, so that is $36, and the other one is 4,700 minus the same prediction, which is $236. Okay, again, let's make the prediction for a committee of 5 people, so changing the 3 to a 5, we get 7420 to the nearest dollar, and so the actual, which was 7,200 minus the predicted, is negative 220 to the nearest dollar. So we've got a negative residual there. That means that the line of best fit is making an over prediction. The actual value is below that prediction. Committee of 6 people. So scrolling up here, changing our number of people to 6. The prediction is 8898. And that'll be the same for both of these. And then the actual, so 8,500 minus that predicted value, is negative $398. 8,800 minus that predicted value is minus $98. Last one, committee of 7 people. So scrolling up here and changing our 6 to a 7, the equation predicts we would raise 10,376. And so the actual, which is 10,000, minus that prediction, is negative 376. Okay, so now if we actually look at plotting our residual values, okay, so plotting the residual values for a committee of 3 people, our residual is 36, so I'm not going to be able to be super precise on this scale, but somewhere in here. We also have another data point for a committee of 3 people, 236, so 236 somewhere up here. Committee of 4 people, residual is 158, it's 150, so really just very much just past there. Committee of 5 people, negative 220, negative 100, 200, so just past there. Just going to make those dots a bit bigger so we can sort of see the plot. A committee of 6 people, we've got a residual of negative 398, so that's about negative 400 on this plot, so 100, 300, 400. We've also got another one that's about negative 100 for a committee of 6. Committee of 7, residual negative 376, so a bit less than that one, a bit more than that one really, and a residual of 646. So close to 650. And so that's our residual plot. Okay, let's have a look at how we can get our CAS, to plot the residual plot. So I've already got my data listed in my lists and spreadsheets. Okay, so in the same document, I want to insert a data and statistics page. So Control I for insert, number 5 for a data and statistics page. And I first of all want to do the scatter plot. So I'm going to have my explanatory variable on the left, so click to add variable. Now because I've done the regression, you get all these extra variables created by the regression, so you're going to need to find your 2 variables. So number of people is my explanatory variable, and my response variable was the funds. Okay, so that's the scatter plot. You can then get the scatter plot to show you the linear regression. Okay, so menu, 4 for analyze, 6 for regression, and number 2 for show the linear regression a plus bx. Alright, and then on our screen we're seeing our linear regression. Now, we actually want to be able to also see the coefficient of determination. There's good reason for that. You're only going to need to do this once. So you want to, as it says here in step 5, if R squared is not displayed, you want to press menu, and then you want to press 6, settings, and you want to make sure that you tick the diagnostics box. Okay, and now we should see R squared. You'll only need to do that once, and now every time you do a scatter plot and put the least squares regression line on that plot, you'll automatically get the equation of the least squares regression line and the value of R squared. Now this can be quite an efficient way to find your equation of the least squares regression line by simply doing it via entering the data in the listen spreadsheet, and then instead of doing menu 414 in the listen spreadsheets, plot the scatter plot and plot the line of best fit on the scatter plot, where you'll get the equation from there. Okay, so then what we can also do once we've got our scatter plot with our regression equation, again we want to press menu, analyze, so number 4, number 7, residuals, and we want to show the residual plot, number 2. And when we do that, we can see the residual plot down here, which should match what we've drawn over here. It's on a different scale, but yeah, the data points are pretty similar to what I'm saying. So that's a way you can see your residual plot. So what we want to have a look at is, one of the reasons we want to look at the residual plot is to get a sense of whether a linear model is a good model. Okay, and so over the page we're talking about testing the assumption of linearity. Okay, so consulting in the residual plot is one way that we can confirm whether a linear model was a good model. And if it wasn't, then we might want to do a data transformation, which is what we'll look at in the next chapter. So in the diagrams below, the data points have been joined with a line just to assist us in looking at any patterns. Okay, so if the data is randomly scattered about the zero regression line, then we can conclude that a linear association is appropriate. Okay, and that's because if we think about what a residual plot is, if I've got a regression line where my data points are randomly scattered above, below, couple above, couple below, you know, etc., then a line is a pretty good model for that. Okay, if the data is fairly randomly scattered above and below. If, however, we're getting a clear curve, okay, so, sorry about that. If we're getting a clear curve, one of these two situations, where the data starts out below the lines, we get negative residuals, then positive residuals, and then negative residuals again, then a linear model probably wasn't a good fit. Again, if we think about, if we think about this particular graph here I'm looking at here, so if I were to think about that, if I've got my line, let's say that's my line of best fit, what this is telling me is I've first got two data points that have negative residuals, a biggish negative residual, a less negative residual. Then I've got a positive residual, a bigger positive residual, an even bigger positive residual. So again, we're talking about above the line, okay? Another positive residual still, and then a negative residual after that, okay? So what I'm seeing here is, oh, sorry, let me undo that. Can't undo that easily without moving my CAS. Let me get rid of the CAS. Okay, so what I'm seeing here is, just get rid of that arrow, sorry, is the data is actually, if it starts below the line and then goes above the line and then comes below the line again, it wasn't following a line, okay? It actually might have been better modeled by a curve. Okay, and again, the same applies. If you've got your regression line and your data starts out above that line and then goes below that line and then comes above that line again, so that you have positive residuals, negative residuals, and then positive residuals again, your data probably wasn't of a linear form to start with. It was of a non-linear form, and so therefore a linear regression isn't perhaps the best way to model this, and we should be using a different kind of regression. Okay, so if the data jumps around up and down and above and below the regression line, that is, if the residual plot jumps around positive and negative residuals fairly randomly, then a linear model was probably pretty good. If, however, we see this clear pattern of negative residuals, then positive residuals, then negative residuals, or vice versa, positive, then negative, then positive, it shows that our data is actually following a curve and perhaps a line wasn't the best fit. And what we'll look at in the next chapter is, okay, if a linear model isn't a good fit, if we shouldn't have used a line of best fit, what can we do to the data to create a better model? Okay. All right. So the second part of what I want to look at today is regression analysis, which is really just bringing everything together. So a full regression analysis on a data set requires the following elements: the construction of a scatter plot, discussion of the association, that is direction, form and strength of the association. So is it positive or negative? Is it linear or non-linear? Is it strong, moderate, weak, based on the correlation coefficient? Calculation of that correlation coefficient to indicate the strength, determination of the least squares regression line, interpretation of the coefficients A and B, use of the coefficient of determination to indicate the power of the association, and correct interpretation of that value, and then possibly using the regression line to make predictions based on whatever the question's asking you, and equally calculating residuals or considering the residual plot to test the assumption of linearity. Okay, so all the things we've done in this chapter, doing all of that with a data set would be considered performing a regression analysis, and then we can obviously summarize those details. Alright, so let's have a look at an example. I'm just going to bring my CAS back up. I'm just going to pause while I start a new document and enter that data in, and I'll come back to you once I've done that. Okay, so I've entered the data in, I've given my columns names. Now you'll notice the data here doesn't have any context, we've just been given X and Y, okay? Now I don't want to call my columns X and Y because in the spreadsheet there is already a column X and a column Y and things get very confusing. Equally, there would be issues if then I don't start a new document the next day and I'm trying to solve an equation with X in it and it thinks X is a column of data. So you should never use a single letter to name a column of data. Okay, so I've called mine X var for X variable and Y var for Y variable. You could just call it XV and YV, standing for X variable and Y variable. Okay, but please don't use just X and Y. You'll develop sort of bad habits that are potentially going to become problematic for you later on. So I've put the data in. Part A of the question asks me to use my CAS to plot the scatter plot and comment on the existence and direction of any association. Okay, so we're going to do Control I for a new page in our document. We want a data and statistics page. We want to put our X variable on the X-axis and our Y variable on the Y-axis. Okay, so we've got a scatter plot. We want to comment on the existence and direction of any association. Okay, I would say there is a fairly strong association there. The data falls into a line, however it's a non-linear association, okay, and there is positive direction here. Okay, so I would say we have an orange pen. We have a strong, positive, non-linear association. Find the correlation coefficient, correct to 2 decimal places, and interpret its value. Okay, so 2 ways we can find the correlation coefficient. Oh, actually, no, we're best to stick with our original way. I'll come back to that in a second. So I'm going to press Control left to go back to my Lists and Spreadsheets tab, and I'm going to do my regression. So menu 414. My X list is X var for X variable, and my Y list is Y var for Y variable. Again, function 1 if I want to make use of that. Results are going in column C, great. Okay, so correlation coefficient is here. It's, if I scroll down, it is to 2 decimal places, 0.96. So R is 0.96, which implies that we have a strong correlation. Find the equation of the least squares regression line giving values correct to 1 decimal place. Okay, so we've done that in answering part B. We've got our A and B values for our regression equation. So we don't have any actual variables, so we're just using Y and X. So Y is equal to A plus BX. A is now 1 decimal place it says, so negative 57.7 plus B, which is 37.9 times X. Use the least squares regression equation to predict the value of Y when X equals 12. Comment on the reliability of this prediction. Okay, so predicted Y is going to be negative 57.7 plus 37.9 times 12. Okay, so negative 57.7 plus 37.9 times 12. Okay, so that is 397.9 1. It should really specify correct to 1 decimal place, because if we used our function definition, f1 of 12, it would have given us, sorry, again I'm in the scratch pad, it's my fault, sorry. If I go, it's my maths methods habits, if I go, sorry, so Control I for a calculator page. If I, again, I'll do that same calculation here, so it's here, minus 57.7 plus 37.9 times 12. If you'd used your function 1 of 12, you would have got, again, a slightly different prediction, okay? So I would tend to stick with, if it's not really clear, use the question from Part C, but I can assure you that you won't be penalised for being more accurate than necessary in subsequent calculations. And usually the numbers are designed so you actually don't get different rounding. So our predicted y value is 397.1 or 397.4 if we use the function definition. And we want to comment on the reliability of this prediction. So remember, reliability is usually asking us to think about interpolation or extrapolation. So we predicted for x equals 12. So x equals 12 is over here outside of the data set, so it's an extrapolation, okay? This prediction relies on extrapolation. So may not be reliable. Find the coefficient of determination correct to 2 decimal places and explain its meaning. Okay, so we've already got that when we did our regression. So going back to our data tab, our spreadsheet tab, we can see that r squared is correct to 2 decimal places, 0.92. Okay, so explaining its meaning, this means that 92% of the variation in y, response variable, can be explained by the variation in x. So we can be pretty confident in our predictions based on this regression equation. Part F, find correct to 1 decimal place the residual for x equals 5 and interpret the value of the residual. Okay, so residual is actual minus predicted. So in x equals 5, in our data set, we've got the actual value of y is 94. So we need to work out the predicted y. To write small here, I haven't left us enough space. Predicted y is going to be using our equation, so minus 57.7 plus 37.9 times when x equals 5. Okay, so let me go back to my calculator screen over here. I could retype that in, or I could scroll, or I could scroll back up here and take this previous calculation where I already used my regression equation and instead make it 5. So my predicted y value is 131.8, okay, which means that the residual is the actual, which is 94. The actual y value when x equals 5 is 94. So we want actual minus predicted. So we want 94 minus 131.8. So my CAS, I want to do 94 minus this previous answer. So we've got a residual of negative 37.8. And interpret the value of the residual. Okay, so the negative residual means that the actual y value is less than the predicted y value. Okay, so the residual means that the actual y value is 37.8 less than the predicted y value when x equals 5, obviously. Use your CAS to construct the residual plot and use it to comment on the assumption that the relationship between the variables is linear. Okay, so I'm going to go back over to my plot. So that's this one here. Now, I think we can tell fairly clearly, this is a pretty clear set of data, that we already noted in part A that it's of non-linear form. So I think our residual plot is also going to show that we shouldn't have assumed a linear relationship here, and that actually the linear regression probably wasn't the best way to make predictions for this data set, even though actually it does have quite a strong correlation coefficient. So it's not bad, but there would have been a better model that we could have used. So again, we've got our scatter plot here. We first of all, before you can do the residual plot, you must get it to show you the line of best fit, the least squares line of best fit. So we're going to press menu, 4 for analyze, 6 for regression, show the linear regression a plus bx, so number 2. Okay, again, because I did that diagnostics tick earlier, I can see my regression equation and my R-squared value, which matches the things I found previously. So now we want the residual plot. So menu, 4 for analyze, 7 for residuals, 2 for show residual plot. And we can see very clearly here that we have a clear pattern in the residual plot, and therefore the assumption of linearity wasn't a good thing. We shouldn't have assumed that a linear model was a good model. So use it to comment on the assumption. Okay, so I would say the residual plot displays or shows a clear pattern suggesting that the relationship is non-linear. Okay, and that's going to lead us nicely into our next few lessons, where we will look at, okay, if the relationship is non-linear and a linear regression wasn't the best, the line of best fit, what can we then do and what are our options? Okay, so the work today is the residual analysis and then combining that all together in a full regression analysis.